Do you mean your theorems and postulates?
No, you really don't today. Well, actually, yes, you do. I'm sorry. There is one postulate that we will write on there today. Okay, so section 1.5 is all about segment and angle measure. I don't spend a whole lot of time on segment measure because I trust that you guys can measure things in a straight line. And you can count spaces on a number line because we've done that a lot. But just some quick I just want to quickly go over the definitions that go with the segment stuff. So length is the length of a segment, right, is the distance between the endpoints. Can everybody read my handwriting okay?
Yeah.
Cool. All right, and then the other one that we kind of focus more on is congruent segments. So, who knows what congruent means? Anybody? All right, so congruent basically means equal. So it's segments with equal length or with the same length. Right, so we will use the term congruent a lot in geometry class. So it means like that they have the same measure, like they're the same size, they look the same. Okay, so the symbol for congruent is an equal sign with like a squiggle on top. Right, so if I wanted to say like segment AB was congruent to segment CD, I would put that equal sign with the squiggle on top between them. Not notes, no. The theorem and postulate sheet, yes. Yeah, I mean, occasionally we'll do some open note stuff, but...
Right, not these.
Not those, but the theorem, postulate, everything on that, yes. But you can only put the theorems and postulates on that. Yeah, so. All right, so nothing in the blue boxes, but green box stuff is okay from the book. Okay, questions on congruent segments? Oh, all right, anybody still writing?
I am.
Okay. I'm gonna record. There we go. All right, so the next one I want to talk about is midpoint. So the midpoint of a segment, it splits the segment into two congruent segments.
You skip order.
Huh? Yeah, I did. All right, so let's say we have a segment here. All right, so it's segment AB. So the midpoint of this segment would be the one that falls right in the middle, right? Hence why it's called midpoint. So let's call it C. And it splits it into two congruent segments. So when you see things that have like these little lines on them, right, since they both have one line, that means that those two pieces are congruent to each other. So like when we're drawing it on a picture, you'll see these little lines here between them. But say like we have another one, right? So let's say I have this bigger segment, X, Y, and I put a midpoint here, right? So I wouldn't use the same one line because that would mean that's also congruent to this. So like even if you see it with like two lines, it means like anything with the one line is congruent to each other. Anything with the two lines marking it would be congruent to those. Does that make sense? Right, so like this means that this piece is congruent to this piece. These two lines mean that XZ and ZY are congruent. Alrighty. Okay, so questions about midpoint. Okay. Anybody still writing? Okay. All right, so now let's go ahead and jump and talk about angles, right? So we went over the definition of an angle yesterday, but now we want to start talking about different types of angles. So the first one we have is an acute angle. So acute angle has a measure between 0 and 90. So it's less than 90 degrees. Right, we know that right angles are what? Anybody remember? Yep.
They're 90, yeah.
Yep, they equal 90 degrees. Right, what about obtuse?
They measure 180 degrees, right?
Well, they can go up to 180.
Right.
So it's bigger than 90, but less than 180. Right, and then we also have what's called a straight angle. And so those are equal to 180. All right, so I know you guys have definitely had those over the years, but it's just always a good refresher. So next, let's talk about congruent angles. Anybody have a guess on what that means?
Angles at equal measures.
Yeah, so angles with equal measures. Okay, and then the next one we're going to talk about is adjacent angles. So those are coplanar angles. So they're angles that share a common side but no common interior points. So let's kind of draw a picture and see what that looks like. Right, so we have this angle here, but so technically here we have two angles, right? We have this one, well, technically three, right? So we have the one that is here, the one that's here, and then the big one that has both of those, right? So let's give all those points some names so it's easier to talk about. A, B, C, D. Right, so we could say that angle ABC, right, so that's this angle here, is adjacent to angle CBD, right? Because they share this common side of ray BC, but they don't overlap anywhere, right? That's what adjacent means. So it means that they share a side, so they have a ray in common, but they're not going to overlap at all.
Can one be bigger than the other?
Yeah, they can absolutely be different sizes. So, like, I could draw it like this even and, like, go like that. Like, those two would still be adjacent, but they just can't have anything that overlaps in them. They have to just be, like, side by side. They don't share anything except that side. All right, does that make sense for adjacent?
If you're writing like angles that are adjacent to the other, how would you write?
I just kind of abbreviate it. So I would do like angle ABC is adjacent to like angle CBD. Yeah. Yeah, there's not anything special because it's not something that we use a ton. But yeah, as long as you abbreviate it so I can tell what you mean, we're good. Because I abbreviate stuff too. Because like it's a pain to be like angle ABC is adjacent to, like that takes forever. So, all right. So, how many of you remember how to use a protractor?
Something that like
Nope, that's a compass. Protractor is this.
Are we writing down that postulate?
Oh, yes. I'm getting ahead of myself. I'm just really excited for protractors. Okay, everybody good with the slide right here? We have one more thing to write down. Okay, so the last one, this is the angle addition postulate. So this can go on your theorem and postulate sheet, okay? All right, and then as we get into chapter 2, we'll talk even more about the angle addition postulate, but I just want to kind of go over it with you right now. So let's say, again, that we have two angles. Okay, I'm trying to kind of use the same letters that they have in that theorem there. Right, so like this can be the picture that you draw for your theorem postulate sheet. So it says if K is in the interior, so that just means if K is like in this middle part of our angle, right? So the interior of M and P. Then the measure of angle M and K, so the measure of this angle, so that's what the little m in front means. So it means measure of angle M and K plus the measure of the other angle, which is K and P. It just means that when you add these two smaller angles up, it has to equal the big one. Right? So it has to be equal to the measure of angle M and P, because it doesn't mathematically or even logically make sense for these two angles to add up to something bigger or smaller than the angle that they're part of. Right? That's all it means. It just means two smaller angles add up to be the big one that they form. Okay? And that one's on page 26 if you want to copy it down. Okay, now I can talk about protractors.
Are we still taking notes,
Kind of, sort of. We're just sort of practicing. I'm going to go ahead and pass out protractors really quickly. Okay, so again, we're going to line the vertex up with our protractor, right? So that dot goes on the vertex. One of your sides gets lined up with your 0 or 180 line. Where's my, there it is. Nope. They keep moving the buttons on me. Right, it gets lined up here. Then you measure up. Knowing that this angle is smaller than 90, you're going to use your small numbers. And it lines up to about 41, 42 degrees because my line's a little squiggly there. But so when I have you guys measure these on like tests and quizzes or stuff, I usually, as long as you're within like 3 degrees, either way, we're good. And so even in your book, some of them, actually, if you're using the ebook where you can like zoom in, it'll probably be easier to measure. But if you're using the paper book, sometimes you have to like take the flat side of your protractor and like extend the line up so it'll reach your protractor. So don't try and use like, because some of you have ones that have like the holes on the inside. Make sure you're using the outer ones because it has the more dashes and you can get a more accurate reading. Okay. So then the other thing I want to go over with you guys real quick is how to use the protractor to draw an angle that's the right measurement. So again, we're going to use the straight edge of your protractor. That's what it's there for, right? So we're going to draw a line. Right, doesn't matter, just give yourself a baseline. Okay, and let's say we want to draw a 130 degree angle. So from your baseline, then you want to make sure and move. Oh, I hate it when I draw it close to that. Can I not ungroup them? Ungroup. Okay. There. Okay, so now that I've done that, I want to make sure and line my like the end of my line up with my vertex point in the protractor. Right? Make sure you move it and line it up with that dot or circle. Then we're going to go, I start just like from where I drew my arrow, and I got to go around to 130. So I'm going to go over to 130. I'm going to put a little dot. All right, I'm just going to kind of make a mark right there with my 130. Then you're going to pick up your protractor. And then, I'm not going to, but you guys will pick up your protractor. Then you will use the flat side of the protractor to connect your vertex and that point. So there's your 130-degree angle. All right, so then when you're done, go ahead and double check it, measure it, and make sure you're getting close to that. Again, I want you guys within about 3, even 4 degrees. As long as you're close, you're fine. But if you're like 5 or more off, we're going to really have some issues. Okay, so any questions on measuring, drawing angles? Okay, because on Friday, I want you guys to go ahead and look at this. So Friday, let me double check what numbers I had you guys do. All right, so Friday we're going to do problems 15 through 24. So like on 15 through 20, it gives you that picture over there, and you're going to have to measure those angles. So if you're going to use it on your iPad, like I would zoom it in so you don't have to worry about extending the lines out. If you're going to use your paper book, like see how I've done it even here, extend the lines out so that you can get the accurate measurements, okay?
Yes, ma'am.
And then on 21 through 24, you are drawing the angles. If you haven't done that, can you guys wait till lunch and not interrupt my class? Thank you. Okay, so I would probably suggest you guys draw those on a sheet of paper and not your iPads, just because that's going to be a little bit easier. I think it's going to be hard for you guys to use the protractor to draw it on your iPad. So just any sheet of paper, I don't care. And just make sure they're big enough that we can like measure them. Don't draw me, now Karis has a smaller protractor, so your angles will be smaller. But the rest of you, like, don't give me angles like this. Like, I need to see that you actually like use your straight edge and measure them out and drew them correctly. Okay? So make sure you guys take those protractors home with you so that you have those to do your stuff. Yeah, okay. All right, so that's all I got today. So you guys are dismissed to go on to lunch. You're welcome.